Hello dear all, I Neeraj Kumar welcome you all in my lecture of algebra where we are going to discuss about geometric progressions. Let us start our lecture here. To understand geometric progression, we have to go with some of the concepts that we had studied in our last lectures, like definition of arithmetic progressions, representation of arithmetic progressions, nth term of arithmetic progressions, sum of n terms of arithmetic progressions, mean of arithmetic progression, and also known as arithmetic mean. Today in our lecture, what objectives we are going to discuss about? We are going to discuss about geometric progressions, nth term of geometric progressions, sum of finite geometric progressions, mean of geometric progressions also known as geometric mean, relation between arithmetic mean and geometric mean, that is represented by here as AM and GM. Let us introduce my geometric progression. Geometric progression, let us consider the following numbers, that means 2, 4, 8, 16 and so on. That is 2 means what? 2 to the power 1, 4 means 2 to the power 2, 8 means 2 to the power 3, 16 means 2 to the power 4 and so on. And similarly I can have this one also, 1 by 2, 1 by 4, 1 by 8, 1 by 16 and so on. And similarly I can say that 1, 3, 6, 18, 54. So how can I judge whether these are in progressions, whether these are in geometric progression or not? So in each of these sets of number, how their terms progress. That is, there is a unique way they are progressing in a unique way, or they are reducing in a unique way. So we note that each term except the first term progression is definite order. State how do the terms in first, second and third progress. So we have to discuss about the same thing, and that represents the GP or some other progressions. It is observed that each case every term except the first term bears a constant ratio to the term immediately preceding it. So let us think about geometric progression. In first, this constant ratio 2, in second this constant ratio is 1 by 2, and in third the constant ratio is 3, and such set of numbers is called geometric progression, in short as GP. In mathematical, we can say the terms a1, a2, a3 and so on up to an, as we are talking about only finite geometric progression, are the form of geometric progression if each term is non-zero and ak plus 1 by ak. That means the larger term divided by its preceding term must equal to a constant value, that is called R, and that is also known as a constant ratio, that is called common ratio. And what is k here? K is greater than or equal to 1. By letting ak is equals to a, we can obtain a geometric progression that is known as a into ar, again ar square and then ar cube and so on, where a is called the first term and r is called the common ratio of GP. The common ratio in geometric progression 1, 2 and 3 above are 2, 1 by 2 and 3. Let us see some example on geometric progressions. Note, a GP is called finite GP if it have finite number of terms or finite number of elements. Otherwise, it will be a infinite GP. Let us see an example here. Which of the following of the GP? If they are of the form GP, find the common ratio also. Common ratio means R. So 2, 4, 8 and 16, it is in GP. Of course it is in GP. 1 by 2, 1 by 2 and 1 by 2. Is it in GP or not? Let us think. Is it in GP? So yes, of course, it is in GP. You can see that common ratio is going to be same here. So 1, 4, 7, 10 and so on. This is not in GP. Make sure this is not in GP because common ratio is not going to same here. What is the general form of GP? That is geometric progression. In case of arithmetic progression, the problem of finding nth term or sum of n terms of GP, that is geometric progression, containing a large number of terms which would be difficult without the use of formula, which we shall develop this lecture. We shall use the following notations with these formulas. So A will be your first term, L will be your last term, R will be your common ratio, N will be your number of terms, and Sn will be denoted by for the sum of first n terms. General term of GP can be represented as, if we define a GP, the first non-zero terms A and the common ratio is R, write a few number of terms of it. The second term is obtained by multiplying by A by R, that is going to be A2, that is your second term will be equal to A into R. Similarly, third term is obtained by multiplying A2 again by R, so we are getting AR square and so on. That means you are getting some terms like A in AR square, AR cube, so on, and 100 and number of times up to n terms. What will be your nth term? Your first term was A into R to the power 0. A into R to the power 0 was your first term. That means I can say that your nth term will be going to be A into R to the power n minus 1. How can I represent for sum of first n terms of a geometric progression? So if you have first term as A, second term as AR, third term as AR square and so on, your last term as AR to the power n minus 1. So in case R is equals to 1, suppose let's R is equals to 1, then in that case your every term will be A and so on. So in that case, what will be the sum? N times of A. It is very easy to understand. Now, in such case where R is not equals to 1, then multiplying my equation R by again. So we are getting R into Sn is equals to AR plus AR square plus AR cube and up to AR to the power n here. So after subtracting my equations, both the equations, so what we are getting here, so that means Sn minus R times of Sn, so we are getting 1 minus R into Sn is equals to A times of A minus A times of R to the power n. So we are getting here 1 minus R to the power n here, so Sn will be equals to A times of 1 minus R to the power n by 1 minus R, or Sn will be equals to this one. So in a similar way, that means I can place the order to their places, that means by reversing them. So we are getting A is into R to the power n minus 1 by R minus 1. So in this case, when your R is lesser than 1, so we are using the sum of geometric progressions by using this formula. And if you have R greater than 1, then in that case you can use this formula. Let us think about geometric mean. Given two numbers A and B, we can insert a number G between A and B so that A and G and then B is a GP. Since the number G is called geometric mean of the numbers, that means what can I say? That means AGP. That means G divided by A must be equal to B divided by G by using the definition of geometric progression. So I can have G by A is equal to B by G. That means I can solve this by using cross multiplication. So G square will be equal to A into B. So G will be equal to under root AB. This leads to a generalization of the concept of geometric mean of two numbers. So given two positive numbers A and B, we can insert as many as number we like between them to make the resulting sequence into a GP. Let m1, m2, m3, m4, so on up to mn be n number of terms that are going to be inserted between a and b. I want to insert these terms, n terms, inside a and b, so that this remains into a GP. So in this case, how many terms will be going to happen? So the total number of terms will be, after inserting, will be n plus 2. So in that case, your B will be at the place of n plus 2th place. That means term number n plus 2. So in this case, B is equals to A into R to the power n plus 2 minus 1. So in this case, you are getting B is equals to A R to the power n plus 1. So in that case, I can have R is equal to B by A to the power 1 by n plus 1. So we can get the value of m1, m2, m3, m4, m5, m6 and mn. Okay, by putting the value of R to every terms. So in this way, I can get every value of your geometric mean and every value of your geometric progression. So by using this, you can also form geometric progression by using this problem and by using this concept. Since you know that mn was nth term that was inserted in A and B. So between A and B, you inserted nth arithmetic geometric mean. So what is the position of this mn? The position of this mn was n plus 1. So by the definition of nth term of a geometric progression, you can apply a into r to the power n plus 1 minus 1. So it is going to be ar to the power n. So you can put the value of r here. So b by a to the power n by n plus 1. So let us define here the relationship between arithmetic mean and geometric mean. Let a and g be arithmetic mean and geometric mean between two positive real numbers a and b respectively. Let a will be equal to what is the a? So let me redefine here that a means arithmetic mean. Arithmetic mean between a and b is given by the average of a and b, that means a plus b by 2, and geometric mean g is given by under root over ab. So if I am going to subtract these two results, so a minus g will be equal to a plus b divided by 2 minus under root of ab. So if I take the LCM of this thing, so what is happening here? A plus b minus 2 times of under root of ab divided by 2. So in that case, what is happening? This is the square of under root a. This is the square of under root b minus 2 times of under root a into under root b. So I can have under root a minus under root b to the whole square divided by 2. So in that case, this will be always positive. So in that case, I can say that a minus g will always greater than equal to 0, or I can say the relation between a and g is going to be a always greater than or equal to g. That means arithmetic mean will always be greater than geometric mean. Let us have some examples here. If am, that is arithmetic mean, and gm, that is geometric mean, of two positive numbers a and b are 10 and 8 respectively, find the numbers then. So am means what? Am means arithmetic mean and gm means geometric mean. So arithmetic mean is the average of two numbers, that means a plus b by 2, that is given by a means a plus b by 2, that is given by 10 here. So a plus b by 2 is equals to 10, and geometric mean is equals to under root ab is equals to 8, that is given inside your question. From equation 1 and equation 2, can I get the value? But I can take square of equation number 2. So what is happening? AB will be equal to 64. So I am writing as equation number 4. And I am taking this 2 in your left hand side, another side. So I can have a plus b equals to 20. So I can have a plus b is equals to 20 and ab is equals to 64. So from equation 3 and equation number 4, I can get the value of a minus b, that will be equals to plus minus 12 by using simple algebra. Now solve equation number 1 and 5. Again I can solve equation number 1 and equation number 5, and I can get the value of A and I can get the value of B also. So what the value of A will be here? 4 and 16 when I am going to take about plus 12, and if I am taking here minus 12, then again I am getting the value of A as 16 and B as 4. So this minus just represents the reversing of the order of your progressions. Therefore, the numbers are either 4 or 16 or 16 or 4. That's all. Let's have some other example. The sum of first three terms of a GP is 13 divided by 12, and their product is minus 1. Then find the common ratio. Let A by R, A, AR be the first three terms of a GP. So whenever we want to whenever if we want to take the first three terms or first four terms, I can put in this way. So A by R, A and AR are the first three terms of the GP. So their sum is going to be 13 by 12 and their product is 1. So AR multiplied by A multiplied by AR is going to be what? Minus 1. So this R is going to cancel out to each other. So from equation number 2 I can get the value of AQ will be equals to minus 1, or I can have the value of A here is equals to, what is the value of A will be here? Minus 1 will be here. I hope so you are able to understand. So now in this case what is going to happen? Substituting the value of A is equals to minus 1 inside equation number 1 and put the value and get the value of R here. So by this equation you can get a quadratic equation in term of R. So from here I can have 12R square plus 25R plus 12 is equals to 0. So this is the quadratic equation in R, and by solving these quadratic equation either by splitting the middle term or by doing what? Quadratic formula, I can have R is equals to minus 3 by 4 or minus 4 by 3. Well, you should apply quadratic formula here. So here are some questions for your practice to understand geometric progression and its concepts more clearly and in a more efficient way. Find the 12th term of GP whose 8th term is 192 and the common ratio is 2. The 5th, 8th and 11th term of GP are P, Q and S respectively, and so that Q square is equal to P into S. And my third question is, if Pth, Qth and Rth term of a GP are A, B and C respectively, then prove that A to the power Q minus R plus A to the power R minus P plus A to the power P minus R equals to 1. Hope you understand today's lecture. So, thanks for watching my lecture here.